Talk about it, how you broke my heart. If I stay here for a little bit longer. If I stay, won't you listen to my heart? Alright. Where we left yesterday, I got the UV stuff down to a point where we have now a beautiful pink and blue mesh. However, it doesn't actually do anything yet, and also I do realize now looking at it that the UV islands that we have below don't really correspond to different UVs, so I don't know if we did it correctly. So the blue and the pink is just the UVs being interpolated. There's no actual lighting code, obviously. What we have under it is a version of the mesh that I've rendered with just the UV islands. Those are the portions that are going to be contiguous in the light map. So the spots that have different colors are where new UV islands begin. So as you can see on the bottom, it's just going to be one UV island, and then when you go up here, you have different ones when you have faces with different planes, right? But the real cool thing is that this flat surface that kind of goes in between all of them gets one UV island, which obviously is pretty good. That's the whole point of it, right? Is to group contiguous surfaces together and all that. And so I think we did a good job of it. At least as far as I can tell. Obviously, this is one of those systems that where there's like 20 different moving parts, and so you don't really know if they're working until the end, you know. So, but anyway, we're gonna be moving on with our lives here in a second. Anyway, so I'm not exactly happy with. Also, I am going to turn it back to this just because it's easier for me to read. I kind of don't like it because my face becomes white, but whatever. How did I improve at programming? It's been 2 years and I still suck. Well, I've been doing it longer than 2 years, but I think a big thing is you got to give a lot of time. I don't really do much other than program, so I think that's why I got better at it. I don't think that there was like any specific thing. It was just like, the next thing I want to implement this thing, and then the next thing, and then the next thing. That sort of thing. But it took a lot of time. There's a lot of times when I probably wasn't learning anything because I was too stubborn or too stupid to realize how to learn. So there's probably a much better way than what I did. So I can't really give that much good advice about it. I think the way I did it was just brute forcing with a lot of, many, many hours. Anyway, so the idea for it was... So what I was doing before, right, yesterday was we did every triangle at once. So every triangle gets its own rectangle. Obviously, that's not what we want to do. That's the whole reason why we have the UV islands. So what I think I was doing wrong is that I was doing this triangle area thing. So I think instead of doing the triangle area thing to determine the light map rect, what we're instead going to do is determine it by the UV bounds. We're going to get a max U and a max V in these bounds, and instead we'll allocate the light map rect with that position. So instead of just doing each triangle at once and assigning UVs, we're going to just make a function that does it all at once. I do mini projects from time to time to improve. Yeah. I think that projects are really the only way, right? But beyond just like saying, just do projects. You know, there's not really much. You know, I'm not. It's not like I'm gonna advocate for like doing these stupid like coding exercises or whatever. I don't think that helps you improve. I think it's definitely projects, but there's definitely some projects though that help a lot more than others. That's for sure. Like what I learned from like, for example, like the Lenia project. I learned way more about programming than I did from the chess engine. That's for sure. And it was like a way smaller amount of time. The Lenia project was like maybe like a month at most. But I learned so much about simd and vectorization and stuff. But, you know, when it comes to like the chess engine, no. I didn't really learn much. I mean, it was a lot of fun and it was a lot of work, but I didn't really like learn skills, you know. And so I think that it definitely depends on the project, yeah, I'd say. So we're just going to take in the whole UV island. And instead of having out UV, I guess we still do need the atlas, and we'll just get rid of that. So we're not going to use any of this. We are going to get the min and the max, obviously. But we want to go per triangle, right? So let's get the per triangle stuff. Actually, let's just go on a split and get it because I'm lazy. I need to cast some of these things, so that's what I'm trying to figure out. Right, so we get the mesh. You have to get the mesh and then cast the tries like this. Yeah, let's call it UVI, which is what I've been calling UV islands. Okay, so we get the points and we get the tries. That's all we need. So try points is obviously going to be the try points, but we need to, I'm going to use I on the outer loop like usual, and we want to go UVI tries. Dude, I'm telling you, I think I'm becoming lactose intolerant. Like every time I have my coffee, I just like my stomach just does not. I get like a little bit nauseous every time. It really sucks. UVI tries count. And then, what is that? I think it's this. UVI tries. I think so. I'd have to look at it, but I think it's that. And then we'll just get the MF equals at MFs with tries I. There we go. Okay, and so we get our mesh face, which is a triangle, and we want to get the points that are in the mesh face. So I'm just going to get vec3p. What is try points? Oh, try points is the first point. Oh yeah, got it. I'm just gonna do it like this. I can't actually call it. We're just gonna do this naming convention because A is the enum. It's strange that it's PA minus PA. Also, something we need to do is we need to what is it? Find least parallel axis. And we can't use the face normal, and so we have to just use the general normal for the UV islands. Does UVI have a normal? Okay, it does. So we're just going to use the UV island normal just to get the general axis. That is awfully strange, but I'm going to assume that it's fine. And then this PU and PV thing is interesting. So this was our per vertex UVs, right? But now we need to keep it for the entire rect for each point. So we want an array of the points that we have already processed. So I'm just gonna make that. It's gonna be but we also want the UVs. Okay, so then we can make it a struct. We can make this a struct. When I usually have to name stuff like this, I go for like a UV pair. But I'm kind of worried about the... I'm just going to call it UV assignment pair. That's a mouthful. I don't usually like mouthfuls like that, but we're just gonna pretend like it's fine. How do I want to do this? I think we just keep the index on it, and then we just iterate through it, and then find which one just by matching the index. Strangely, like usually there would be a faster way of doing this, but I actually don't think that there is. I don't think that there is. Because if I just allocate to the amount of MF indices, that's an insane amount for this. Like it would be like literally, you know, for a certain mesh it would be thousands and thousands of triangles, maybe even a million. So I think for now I'm just going to store the UV, and then on the index I'm literally just going to match with I'm just gonna match with happy streaming. You have some great stuff again. I'll be keeping an eye if I can. Thanks a lot. I really appreciate that. I think we're just gonna keep the index here and then just match on the index. It kind of sucks because depending on how big your UV island is, or no, how many, depending on how many points and faces you have, you could, because you're gonna check for the index in the whole thing. I was thinking hash table, but it would still be sucky. Oh, here's what you do. You keep a separate array that goes to face count, that stores the indices that go into the assignment pair, and then that's the fastest way to do it. Yeah. Okay, got it. So we don't need index in here. We're just gonna have a separate array of indices that map back into the UV assignment pair. So that's what we're doing. No, you still need the index because you still. Oh god, my fucking lung is always doing this shit. Ever since I got my lung collapse and had the surgery, it's kind of whack. I'm just gonna have the index in here, and then we'll match once when we're emitting indices, and then next time we'll have it per face. So that's what we'll do. So we're just gonna allocate these. And we're gonna go to the maximum amount of points, so UVI tries times 3. And then we'll also just do I meant to go tries that count. So every time we process a triangle, we'll find the UV pair if it exists, and if it doesn't exist, then we'll God, it fucking hurts. Okay. So we will go through then we need to make a new UV pair, right? So UV pairs index by UV pair count plus plus equals we might actually you know, it is really convenient to just match on indices, but now I'm thinking like if we have any point deduplication, then we're gonna unwrap our UVs fucked up. So I'm thinking maybe we just voice crack. I'm thinking that maybe we just manually check for equivalency. So that's what I'm gonna do here. Sure, it's gonna slow us down a bit, but I don't even think it's my lung. I think it's just my heart sucks. I don't know, man. I don't know how many fucking years I have left in me at this point. It kind of blows, but we're gonna have an epsilon of 0.001f. In fact, let's just have a const. Okay. Sorry, I'm trying to talk less because of my pain in my chest right now. We gotta make sure to free these, so that's what I'm gonna do next. Okay. Now Malloc and free. Oh my god, Malloc and free suck. In this case, it makes a lot of sense. This is our offline light map renderer. We don't really care. All right. So now that we have our min and max U and V's, we can calculate the amount of space that we need. So this we already have is range. And this textile is per UV unit. I don't really remember what we did. I think it was 4. So I'm just gonna okay. And that is technically what we will use to allocate our rect. Okay, there we go. So now we have allocated our rect to those bounds, which is no longer just per triangle bounds. It should be the whole UV island. Okay. And then that is at the bottom. That's what we did already. We're gonna go per triangle, per point, find the references, and then calculate this. So we're gonna loop again. And this time we're gonna use the rect bounds that we have over here. I forget also where my lightmap rect gets saved. I think it gets saved in the UV island itself for when we bake. So I'll just do that right now before I forget. Okay, so now we want to loop through all the tries again. Have a good stream. I'm also making my own 3D engine, but it's in JavaScript and WebGL. It's a World of Tanks like game. Oh, that's interesting. That's really cool that you know, like things that you can play in your browser or whatever is like really cool nowadays that they have. It's pretty crazy that the computers are getting that powerful, you know. So we have UV pair indices, which goes into UV pairs. So UV pairs indexed by UV pair indices, and we'll have just a moving index. Alright, so we get the PU and the PV out. Oh yeah, the theme is actually not that. It's modus operandi tinted today. So yeah, that's what it is today. Sorry. I don't really very often, you know, change the commands or whatever. Yeah, no problem. Okay, so I think we're gonna keep the same calculation pretty much. I think it works. What did I write down for the pixel U and the pixel V? Rect X plus padding plus U times usable width. That's what we have already. That's what we have already. Or is the, hold on, inner, our inner is the padding. our inner has the padding. We want to get rid of this, by the way. Our inner has the padding, though. Rect plus pad. But that's our inner U, yeah. Yeah, I think that's it. Oh, yeah, it's right here, yeah. I need to get rid of this. Obviously, this out UVs isn't going to be going to out UVs anymore. So I think we have the UVs here. Where do we allocate them? We allocate them here. Okay. Well, we'll just allocate them beforehand, and then just do all of this. And so this will go to UVs. And obviously it's not going to be... Oh, wait, it is... No. Yeah, it's this. The UVs of the UVs. This UVs is our per triangle, and this is our per point. That's why it's like that. Okay. Alright, so let's figure out how to call this function. Basically, this does everything inside of it. So wait, I have this in the header file? I don't. Did I define this elsewhere? Oh. That would be why. Okay, I'm just going to comment all of this out, and then we'll call assign UVs. Think I'll be here for another 40 minutes. Already night for you. You're from Russia. That's awesome. That is awesome. I'm quite a big Russian literature fan, and also a Russian cinema fan, you know. So alright, I don't know what we're compiling into. We have an index that's out of bounds. Where does that print out from? It's definitely not in here. It's definitely in like render fill. Is it this? Yeah, it is. Try UV IDX. Oh, I think I got rid of something that's necessary here. The fact that it's the exact same thing is kind of concerning to me. Like, I expected to see something different with it. So I'm kind of worried. For example, if I get rid of index plus plus, the whole thing is still pink. What does my shader look like? At least that's light blue. But the rest of it is kind of doesn't have a thing. I think 0 is completely opaque, which seems weird, but yeah. Maybe they do have slightly different UVs. Yeah, like this one's a different color. Learning C, I mean zig. Oh. Yeah. It's quite interesting that many people admire our country, but many of us hate it because we have a very tense situation and the authorities are doing complete nonsense. Yeah. I mean, just like looking at the history of Russia, that's kind of always been the thing, is that the government, has always, even, in like the 1900s, has always been doing complete nonsense and, taking what they please. And the rich people in, Russia have always ran things in a very rich people way, so it's like, yeah. But at the same time, like, Russian art, because of that, is just like, really brilliant. And it's always been like that. It's been very, political and very, very, very important to me. So that's why I personally admire it. There are rustlings and there are ziglings. Are there clings? I don't know. I think mainly the people that write C are just humans. That's what I think. I'm going to assume that I did this correctly. But it is strange that nothing changed. Does that mean that I was just doing this right the first time, or? I might have been doing it right the first time, I guess. I have no way to test it, really. So, I have no clue how I would begin to test it. I want to test it because I want to make sure that we did this correctly before we move on. This find least parallel axis thing might not be the way to go. I don't really have my reference code anymore, though. I deleted it, so. We could print out what the... Yeah, I have a feeling that these are all getting the same UVs. Because this is inner plus norm. Yeah, I don't know how you're number one. Yeah, I have no clue how to debug it. I think, to be honest, all we can do is move on and then try to figure it out as we go along. The next thing, I had this wall here which tells us how to how to sample the... We sample it with just VUV. That's all we do. It's just VUV. Okay, so let's sample it with just VUV, I guess. It should all be one color now. And it's all black. Okay. Do I call bake light map? I don't think I do, actually. I don't think I call generate UV light map. I do call generate UV light map. Well, we're gonna have to do some detective work here. I want to see what indexes as we go through, if our indices are valid. They're pretty large, but not unbelievable necessarily. I kind of want to see if we can just upload the whole thing, because this GL text sub image 2D doesn't actually allocate the thing. If we just go text image 2D and then just level internal format. Internal format is GL RGB A32F. And then what else is in the middle here? Width is going to be what is rect width and rect height? Texel max minus texel width. I guess so. Border. Format GL RGB A. Oh, GL RGB. It has to be GL RGB 32F. Okay. We get rid of this stuff. I don't really know how that stuff works. Oh my gosh, that was how long it took to load. Okay. Oh yeah. So start just upload the full UV buffer. I'll have to get rid of the index printouts. It's not telling me anything. We seg faulted. Oh, I took a pointer to a pointer. My bad. Yeah. Let me get rid of this so that we can go fast. No, nothing. Let's see what the UVs are. All relatively very, very small. But I don't think that that's ridiculous. Whoa, Neovim with an eye-killing theme. It's Helix, not Neovim. See if we have duplicates. We do have duplicate UVs actually a lot, which is what I was worried about. But even if we had duplicate UVs, we would still be writing to those locations. Alright, peace out. Still would be writing to those locations, so... Now they all should be writing to different locations. Something I could test is if I just if I just add some random numbers to it. If we could just generate some space. Anyway, what I might just do is add now I'm just generating fake space by putting them far away from one another, but it doesn't seem to be doing anything. What's also confusing is why are... Well... No, yeah, both of them are. Why are PU and PV not different? PU and PV should be two distinct things. Each time. I want to see what those are. Yeah, that's what I thought. Let me see what they are beforehand. No, they on calculation are Incorrect. Oh shit. UVI normal is probably not getting initialized when I create the UV islands. Yeah, I don't think I ever go island normal equals normal. Okay, well that's that bug solved at least. It is strange that the first one is 0 every time, but that actually makes sense because of what I was saying earlier with this thing. But I think that that's the way it always was. Let me see this reference code for it. Had to be somewhere around here, right? Try points I minus try points A. Maybe instead of points.pa, maybe we choose the first one of all of the triangles. I think that's what we're supposed to do. Because if we're thinking about it in a rectangle, we're probably supposed to be doing it versus the first one. What is try 0? Now we definitely differ more. But now if I bring this back, then we should have less duplicates going on. It's still black. But then again, I am adding this random value. Rewrite in Zig now. The fact that it's 0 sometimes really worries me. But I guess it has to be 0 when it hits the first point again, but why is it hitting the first point again? Maybe because they share the point, yeah. Does that make sense? Did I write my kernel yourself? No, I didn't. No, I didn't. It might be a good idea to print out the triangles, but this is starting to worry me. I want to test if we can Oh, there's a hair in my mouth. I want to test if we can get anything out of this. I mean, how would we write to 0, 0 anyway? Let's just try to write to 0, 0 and then see if we're tripping out here. Because we might just like not be reading anything. Let's go UB buffer 0 equals. Let's just see if we can. See, that's what I was worried about. Sigbold speaks, and it's just doing shit. I guess. See, this is what I was worried about. Why would us just doing this not work? Am I uploading it wrong, or do I not have the texture bound? Or so let's try and figure that out. So I have a feeling that do I have to do 1? I don't think so. I think that it's 0, yeah. Yeah. You can compile to both Linux, Mac, and Windows from Linux. Yeah, that's really sick. You could also do that in C. Like, I don't know, whatever. How do I initialize it? Initialize it like this. Init lightmap data. I do call that, right? I do. Why am I doing this project? Just for fun? I want to make a game with it, probably. Why does this not work? Handmade hero? Yeah. Yeah. Not really, but yeah. Yeah. He's really cool. Oh, hold on a second. Fuck off. Can you please? Thank you. Oh my god, I'm so fucking stupid. I was like, why are we not drawing to the screen? Oh, because I have a stale variable going around that's the wrong thing. Fucking idiot. Okay. We've just got one line in it. Who knows what I fucked up trying to get that to work, though. Who knows? Let's try going back to this. Oh, I got rid of rect width and rect height. I don't really remember what those were, to be honest. What were those? Oh, it was just the min. Oh, it was just the min and the max. Yeah, still the line. Okay. Is the bug that the sky is black what I'm searching for? No, the model. I'll show you what it looks like. There's a copy of the model above it. That's where light mapping. This is the UV islands that make up the light map. But yeah, what I'm trying to do is I'm trying to make it so that this is, you know, this has light on it, and it samples the light map and then gets light on it. That's what we're trying to do. So yeah, I assumed that wouldn't change anything, but now we can go back and do the test that I was doing before, though. Like, I want to see what happens if we get rid of this, for example. Nothing. That would make it so that everything gets unique UVs. Why do I multiply times atlas width and atlas height here? So like my old method of doing it, by the way, and my old engine. And so I've been trying to like figure out why I do some of these things, but this to me makes kind of no sense. See, here we get stuff. I mean, it's not like a lot of stuff. It's just the stuff on the side. That's what I was wondering. Not smart enough for this. It's not that complicated. It's not that ridiculous. Now let's try to upload the full thing just to see. No, it's the same thing. Yeah, I figured it would be the same. I was wondering why we multiplied there. But at least it kind of looks like we're not supposed to multiply. Min x is the min of the UVs, and then the max is the max of the UVs for the triangle itself. I don't think that these matter. I think that this is old code. Well, maybe the problem isn't in how we iterate it, but how we assign the UVs in the first place. Maybe I'm not supposed to do it, but I thought that it made sense to assign it for the first one and not the... Let's try it. Why not? Let's just try going back to doing it per triangle. No. Let's try getting rid of texel width. No. We can try raising some of this stuff. Like maybe our constants are getting in the way or something. No. Why would the top and the bottom not get it? Why would the top and the bottom not get it? Maybe it's not -1. Good luck with the project. Maybe see you another day. Thanks. I'll definitely need it. It doesn't appear to be doing anything. Maybe if we don't align to voxel centers. No. Ugh. Hey, what's up, Anna? I'm lost in the sauce with this stuff. With figuring out how to assign the UVs. When I did just UV X and Y, it was really, really blue on the bottom. Really, really blue. So maybe the stuff on the bottom gets really fucked up UVs. Kind of want to go by Rivers. All right, that's cool. I'll call you Rivers. Let me see how I project the UVs, how I used to project the UVs. I used to do this. Maybe I should be doing that instead. Let's try it. Oh wait, so we just get the normal first. Maybe I should just do this. Hold on. Maybe I should just, maybe it has something to do with degenerate faces, or not degenerate faces, but faces that are axis aligned. Well, I turned on the UVs again. I didn't mean to do that. Maybe it has to do with that. No. No. We have to visualize this somehow, what's happening. I wish I knew how. Let's try allocating each light map rect to like a large portion, like 64 by 64. 256 by 256. I doubt that we're running out of space here, but yeah, no. It's the same exact thing. No matter what we do, it's the same exact fucking thing. I think it's interesting that we end up getting negative UVs. Like, we're getting negative UVs, like, all the time. We don't have anything that handles it. Yeah, I think we might have to, like print stuff out more at this point. I want to know what the norm UV is. Alright, so let's see. When normalized, they seem okay. Let's see some of the negative ones. These just go to 0, yeah. Oh, yeah, that makes sense. 256, 243. That's the pixels, yeah. $276, $158. I want to get the final values because that's actually what's relevant right now. This is actually reassuring me because this actually seems correct. This actually seems correct. Let's try a padding of 0. It is strange that it happens on the side and not the tops. You're at this point you're kind of thinking like maybe it has to do with the z-axis. But I have this here that handles that. Let's try a more aggressive thing. No. Okay, maybe it isn't how we're assigning the UVs because now when I'm looking at this, it's actually looks to be doing it, you know, what it needs to be doing. Some of these get duplicate values, but they're duplicate points. Yeah, they're duplicate points. So yeah, maybe it is how we're indexing them. Hmm. Hmm. This actually is supposed to be times. It's actually supposed to be times atlas width for sure. There's no way that that isn't supposed to be. It's the only thing that makes sense. Some aliasing artifacts, but it's definitely supposed to be that. It's the only thing that makes sense because you divided earlier and now you're iterating over the pixels themselves. Am I really sure that this is inner width -1? I don't think it is, but it actually didn't change anything last time that I tried it. Removing the padding did nothing, which is kind of surprising to be honest. I think we should just like play around with it a bit. Like give it like some insane padding and see. Yeah. Yeah, the padding is definitely a part of the problem. If you want to have that much padding, then you have to allocate more in texel space. See, now we're getting somewhere. It's like the texel width has to be higher. Okay, so I'll write a note here about why this value has to be high. But really that high, really? It's kind of crazy to me, but maybe it makes sense because the numbers are super small. It's kind of not working anymore though. Like, no matter how high you make it, it's like it's not really changing anything. On the top at least. That helps on the bottom. Helps on the bottom, but not the top. Are we sure that it isn't voxel centering? Nah, I mean, I don't think so. I don't think so. Yeah, I don't know anymore. This is such a fucking pain in the ass. Why does the top not work? Why would the top not work? Yeah, the way I allocate it should be fine. Yeah, let's just try this. Yeah, it's the same. Let's see. You know what, actually? Hold on a second. Oh, shit. UVI tries isn't a mesh face, is it? Oh, shit. Oh my god. Oh my gosh. Oh my gosh. Oh my gosh. I was sitting here so confused. I was so confused. But this is... It doesn't matter. Does it really not matter? I guess not. Because at the end of the day, we're not even touching it. So it doesn't matter. I do get the UV IDX for the whole try. And then index it by P. That is correct. That is correct. And where do I give the UV island? I give it here. I wonder if there's somewhere else where I cast that to the incorrect type. I don't know. I cast it right there. V's I, UV's J. Like forcing the size tells us nothing. I don't think you can make it like higher either. Yo, what's up, Mojo? Yeah, making it higher doesn't do anything. Right now what I'm working on is I'm trying to make a UV unwrap for the light mapping. But I'm struggling because I feel like I'm doing everything in my ability and it's not enough. It's not enough. The top appears to not work. Let's go back to looking at just the raw UVs again. Yeah, it follows the same thing. Like, the stuff in between is the stuff that doesn't get anything. Maybe I'm supposed to be going... No. I thought that there was something weird that I had to do that last time, but I don't think I do it here. No, yeah, I just do this. Yeah, this is what I use to do the voxel light maps, but for this stuff, I don't think I did. I could once again do UDIR and stuff per triangle and see if that works. So let's just try it. But then if I do it per triangle, then you lose the whole point of a UV island, but maybe it doesn't matter. I mean, this is gonna fuck everything up if I try this, but whatever. It's worth it because I'm kind of stuck at this point. I don't even know if this is gonna work though with the current layout of things. I probably will have to change some things just to test this. So that sucks. Okay, so now the UDIR is local for each triangle. Gives us the exact same thing. Let me see the islands. Is that all on one island? No. It seems like it's sampling off of the texture is what it looks like. Instead of doing the UV island, we could also just do one triangle at a time. Which would suck. But it might be the way to at least get it working for now, I guess. I don't know. You move PA in here, and then it becomes tries I, indices 0, and then from here you put this at the top, and then you just move this inside of there. The range U and the range V is, oh right, you have to, because you need to find the min and the max, you have to. What's my reason to use Windows? I have a very shitty Windows PC, which makes it so that if I use Linux with these NVIDIA drivers, it just doesn't run well, and I need it to run well for these things because I do graphics programming. So that's the reason I have to use Windows. If you go back and look at my streams, it was all Linux all the way through. Okay. Now, theoretically, that should be pretty much equivalent to what we had before, but with per triangle things going on. Motherfucker. What? What's the problem? What? Points MF indices 1. MF is trizi. MF trizi. That indices 0. Indices J. Okay. What? What did I do? UVs P. I allocate that beforehand. But I probably am corrupting the stack somehow. As fair, open source NVIDIA drivers. Yeah, it is. It is. Because this laptop is really old, and so the new drivers just simply aren't supported. And the way they release them on Linux is kind of like they do it in like batches, so that they have like 580 or whatever, and then they have 590 or whatever. They don't have 583.3. You know what I mean? Which is what I need. I need a 540 something exact driver version, or else my computer doesn't work, you know? So that's kind of the thing. Should go back to debugging. Yeah, I hope that that's going well. Yeah, so that doesn't tell me anything. This tells me actually nothing. Because we malloc out and then assign UVs. So somewhere I'm going out of bounds. There should be MF indices 0 technically. Somewhere I'm going out of bounds. We could try -1 here, but I don't think that would do anything, but here I would never go out of bounds. Because this goes to tries.count, which is what we allocate it to. Let's see if it randomly tells us something earlier. No. That makes no sense. We try removing the bake itself. Oh fuck. Oh fuck. Oh fuck. I just realized what it is. It's we didn't go in here and set what the we didn't go to mf UVIDX equals I. That's what we didn't do. By some prick I used to know. Oh, that sucks. Did they mean to do it or was it just by accident? That actually seems a lot better, just to be honest. That actually seems a lot better. And then you can choose just the first triangle. So MF's tries I tries 0. And then that should help us project across all of them at once. Doesn't really seem to change a goddamn thing. It's 0 remorse. So no, it was on purpose. Oh yeah, that sucks. Sorry to hear that. Okay, it's still not really fixed though, because some of them are still not lighting up. Yeah, some of them are still not lighting up. Fuck. This is getting on my nerves. So there's really no way I can debug it, really. Have I tried X times atlas width plus Y? Have I tried that? I don't think that would be it. Yeah, I just use Y times atlas width plus X to write into it. So yeah. There was no other math here. I'm looking to see if there was any other math that I'm missing. But I'm not missing any other math, I think. So UV0001 X and Y, X and Y, X and Y. That's exactly what I do, right? Yeah. We are still doing just like a partial thing, so I should probably try doing a not partial thing. Yeah, it's still is not lighting up. Something like this is annoying because there's really no way to really debug it. It feels like. You could also just like do this per triangle, and now we have basically exactly what we had last time. But that doesn't seem to work either. Everything has the same exact problem, which is the same exact UV islands. Just end up black. So I wonder if it's something to do with the islands themselves. But yeah, I have no idea how to fix it. I kind of want to run it back before we fuck up the undo shit. We need to run it back. That's the truth here. That was just for testing purposes, just to see. Maybe our epsilon for checking duplicate vertices needs to be changed, but I mean that's just an unwrap thing. That isn't even. See, like this just looks like it's going off of the map. If it would be pink, then... Oh, if it's pink, then the red gets raised, right? So as the red gets raised, it's going over in U, right? It's going over in U, and when it gets to higher U's, then it starts stretching and breaking. I wonder if my allocation is correct. Let's see what my block size is and those constants. I wrote it with a block size of 4. Let's try a block size of 8. Nothing. Big hole, nothing. Yeah. Yeah, why do I have a feeling like today is gonna be a bad day? Yeah, it's the same problem. It's the parts that rise up out of it that don't get it. Hold on a second. I just had an idea. Hold on. Does it matter? hold on. Let's not have a translation component, and let's not render the debug thing. Let's not render the UV islands anymore. I want to see. No, it didn't change anything. I was worried that somehow the UVs were getting interpolated based on the model matrix rather than the, you know, and warping it somehow, but I don't think so anymore. Yeah. Okay, well, it was a nice try. Now time to see. I think we did our stride correctly, right? 2, 2. And what is this again? This is normalized, yeah. Well, that's 6 plus 2 is 8. I'm stupid. Don't tilt. Don't tilt. Don't tilt. Don't tilt. Don't tilt. Don't tilt. You're in your happy place. You're in your happy place. You're in your happy place. Alright. My bad. I set up the vertex layout wrong. So, all of my light mapping code is correct, so. Yeah. Well, I'm glad that I didn't go down the rabbit hole of like trying to fix it like too bad. Like I was trying to keep the undo history okay so that if I did fucking fuck it up real bad, then we wouldn't have to recode everything. So just be happy that I don't have to sit here and write it all again because I tore it up. I didn't tear it up this time, and we're fine. We're chill. We're chill. How long was that? It's 2 hours? Alright, that's not bad. That's not bad. That's not bad. 2 hours, fucking nothing, bro. Like, whew. It could have been way worse. That could have been way fucking worse. That could have been so bad. I could have been here for like 5 hours if I didn't find that. I would have literally been here for 5 hours. Like, you'd have no idea how bad it's been before. We're so lucky that we got it figured out in 2. Never let me anywhere near a vertex layout ever again. Like, I need to build an abstraction over that like I had in my last engine so that that never happens again. Okay, if anybody wants to know what the issue was, it was that I had this instead of that. Just one little integer, one tiny little integer. Alright. Let's move on with our lives, fellas. Let's move on with our lives. Okay. Okay, so this is the next part that we need to figure out. Is the compute barycentric. I don't think we need it with the bias. We're doing this much better nowadays. We don't need any of that. What we are going to need, though, is we are going to need to figure out the world coordinates from the U and the V's. Or actually, no, I'm just stupid in the head. No, you do. Yeah. This is necessary. This is necessary. I stole this from somewhere that I don't remember the source, so sorry. Actually, I'm pretty sure that I have this same exact somewhere else in the utilities header already. Somewhere. Triangle area is similar plane. Okay, I guess not. I feel like I did. I think that I have it in a different file. It's how I did the clipping logic. So we're just gonna pretend like we need to rewrite this though is the thing. We need to rewrite this though is the thing. Because this is written stupidly, so I was just really lazy when I stole this, and now we have to fix it because I have a bit more self-respect now. What is the P that I pass into here? The P that I passed into here was PX and PY, which is the unvoxelized coordinates into here. So I have to remember to do that, obviously. I already have it here. Okay. So the float pointer stuff can stay. That's completely fine. All of these need to go to X and dot Y. So we are going to do this. The bias thing was super weird. I think you do have to check for nons. You're cold? It is hot here. It is really hot here. I'm realizing that these should be vec2s. I immediately regretted that decision. Nah, it's fine. I just have to write some code. Bring that heat wave to you. I don't think you would want it, to be honest. It's kind of not that great. Oh, fuck. Oh, fuck. Fuck. No. There we go. Excellent. Excellent stuff all around. It's 45 here every Christmas. 130. Dude, that's not Christmas. I'm sorry. I'm sorry, but that's not Christmas. You've been lied to by the weather. It's not Christmas if it's cold. If it's not cold, that's not Christmas. The best, our Christmas is better. Highly doubt that. Christmas in New York is the best thing actually ever. So our Santa is on the beach in sunnies. I don't want to know what a sunny is. Don't explain that. Don't explain that. Do not explain that. Alright, so what we used to do is we used to raycast and determine occlusion, but instead what we're going to do is we will go out and have a nice little bath. No, I'm just kidding. So we need a secondary buffer. A secondary buffer that stores all of our baking energy shit. Don't you agree? We need that. Sunnies equals sunglasses. I see. It's so crazy to me that's reality for you. That's kind of crazy. I could never imagine it, bro. Like, he's just not wearing a coat. Like, bro, that's crazy. That's crazy. That's crazy. That's crazy. So each texel is gonna have a light map. Didn't I make a thing? A light? No, not a light type. Light map texel. There we go. So it has a position, a normal, and all of this shit. Except it doesn't really need a position or normal. Or actually it does kind of need a position. How are we going to do this? I think we need to initialize them first. But our texels are going to be the same size as the buffer, as the UV light map, right? Yeah. No doubt. And it's just going to be in integers from 2048 to 2048. So to do this, we're just going to put... I'm just going to malloc it just straight up because I just don't give a fuck. I'm just really cool and I don't give a fuck. They're called patches, is what they're called. So that's what we're gonna do. We're gonna malloc size of light map texel times atlas width times atlas height. Now that's a lot, actually. That's 2048 times 2048. Use of on what? Use of on what? Use your words. I can't see what you're mad at even. No definition found. Oh. Do I want to call it a patch or a light map texel? I think we're going to call it a light map texel just so that we can be super understanding and explicit. And at the end we're just going to free them. Because they're only used during the bake. During the bake. Absolutely baked. Fried. Fried out the wazoo. You feel me? Okay, so from here, what we're going to do is we're not actually going to bake here. We're just going to determine the position for each of the texels of each of the triangles. We're going to put it into world space. And then each texel, we're just going to put it into patches. We're just going to, instead of going into here, we're going to index into the patches. Give the position, the normal, how much current energy we're giving it. Is this a vec3 or a float? It's probably a float, huh? Bro, I don't know. Don't ask me. I don't know how to do this shit. And which triangle it belongs to, and we're gonna put it all in the light map texel. And then And then we go through each light map texel and then do our business. Yeah, but then the problem is when we're raycasting out from a light map texel, we still have to go to the triangles. We still find triangles. And then the triangles go to the triangles and not the light map texels. Fuck. Damn. Shit. Fuck. Shit, fuck. Damn. Fuck. How do we get to the texels from the triangles without it being like all of these fucking Fmaxf operations, bro? Like, do I need a BVH for the light map texels? Is that crazy? Because I have one over the triangles. Maybe a triangle stores just a flat array of the texels that it corresponds to, so that we don't have to do all of this fucking bullshit with the UVs, brother. Because this shit seems super expensive for the amount of times we're gonna have to do it. I'm talking about, like, we're gonna have to do this like a billion times because of how light map baking works. Oh no. Oh no. It's gotta be a better way. I'm thinking we initialize it and then per triangle we just straight up have an array. And then we get rid of that later. We just straight up have an array that has all of the texels that it corresponds to, from min y to max x min this. So that we don't have to do this shit. The compute barycentric also is expensive, by the way. Like, don't even get it twisted, bro. Don't even get it twisted. But yeah, we could store that all after computing it once in the triangles data. We just put it on the UV islands. Just put it on the UV islands with the other data. Malloc that shit once, brother. Actually, you know what? I just had like a brain blast. Holy shit. Okay, I get it now. We're just gonna make it a part of light map UVs. Like, high key, just like straight up put it in here, bro. Either that or Biker Santa. Biker Santa sounds badass. Biker Santa sounds top. Is it just me or did typing X kind of suck? Is that just me? Oh, but you have to compute the barycentric coordinates for each one. Damn. Damn, bro. We're really for real about that? Maybe that we do during the shit, but like, bro, That's that's not right, bro. That's like so much fucking work, bro. That's actually like, how many ops is that? How many ops is this? Oh, it's actually not bad. Yeah, 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 yeah. This is just a bunch of multiplication. Yeah, 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 we're chilling, we're chilling, we're chilling. That's not bad. That's not bad. That's not bad. We got to be efficient with this because you know, for reasons, right? The helix control, it's Vim, but not quite. I guess. I mean, I got used to it, and now it just makes me fast as fuck. All of our shopping centers and stores have all winter Christmas decorations, but it's like fucking cooking outside. Yeah, bro, that's got to be wrong. Santa Lolly Run. The fuck are you talking about? What? What? The fuck are you talking about, bro? What are you smoking? Bro, what are you smoking? What the fuck? Wait, so we get the BVH, we get the triangle, we get the UVs for said triangle, and then we need to find out if it's in the texel, though. We need to figure out which texel our ray hits. Damn, what the fuck are we talking about, bro? How do I do that? Oh my god. So I find the UVs for the texel. Then we center it. Shit. We're scaling it by B0, which is the barycentric. Barycentric. All we need to do is figure out how big a texel is in world space, and then we're Gucci. Lollipop Run. A guy dressed up as Santa jumps on top of a fire truck and is escorted by fire trucks and police cars, while he drives by every door chucking lollies at people waiting outside. Everything you tell me about Australia sounds like fucking something Hunter S. Thompson would write, bro. Like, this is like straight up like how many drugs are you on? Like, what are we talking about, bro? What are we, like, are we serious? What the fuck are you talking about, bro? Bro, I don't have points? What are you talking about? I don't have points, bro. Bro, you gotta work with me here. Oh my god. I don't know why, but like, Helix doesn't like, or Clang doesn't like my macros. It doesn't like my macros. Like, it just doesn't want me to be a thing. Why is tries declared there a bad thing? Oh, because of that. Don't worry about it. Don't worry about that, bro. Some towns in the USA do it. Every town does it here. I literally have never heard about that. That like sounds something that like some like drunk old guy would tell me in a bar. Like, have you ever heard about Santa Lolly Run, bro? Back in my day, they used to be like on fire trucks and chalking lollies at all the kids, bro. It was absolutely bazonkers. Like, that's, I've heard that story before, but not really. But yeah. That is such a drunk bar story, bro. Like, what are you talking about? The push away we don't care about. Because we're not pushing away anymore. Guys don't have good Christmas culture. What the fuck, bro? That's so wild to say. That is wild to say. That is fucking wild to say. What? Good Christmas culture. That is fucking wild to say. I gotta be honest, that's crazy. Your Santa is locked inside all day, chugging hot chocolate, freezing. That's the best vibe. It's literally the best time of the year, bro. Does your Santa ride a Harley? No, he rides a fucking sleigh, bro, with fucking reindeer, bro. Okay. So how are we going to do this? We have our position of our texel. The problem is we need to figure out... Oh my god, this is so fucking stupid. Is it stupid that I want to like build a AABB for each texel or something like that? Is that stupid? How do people do this? Can I Google this? Nothing is gonna come up if I Google this. Nothing is gonna come up if I Google this. How do I UV light map check against texel bounds? How do people do this? Checking UVs against texel bounds. No. You misunderstand. You misunderstand. UV light map during bake. You fucking idiot. No. I need to figure out how to propagate the light, bro. What's the answer to this? Ray emissions. Yes, they're cast from the center of the light map texels. Yes. Okay, now it's just giving me unity, bro. Like, I need to know how to... Ray tracing? No. This is ray casting, bro. Which engine or software are you using? Unity? Unreal Engine? Or Blend? Shut the fuck up. How many pixel is the texel? I don't know what the fucking pixel is, bro. Okay, we can determine the texel bounds by literally just going like, how do we do that? How do we do that? How do we figure out how much a texel is in world space? I don't think that we have the ability to do that, is the problem. Because all of our shit is unwrapped, like, based on UVs and not, like, based on world space, bro. Like, we have texels per UV unit right here. So, technically, you know, like, if we just, like, define this, maybe we can find a way. We're just gonna make this a define. And then from here we can probably... Texels per UV unit. So the way we do it... Sorry, I'm not... Christmas on the beach with barbecue. That's not Christmas. Your son doesn't have a bunch of fucking flying kangaroos. Anytime I Google anything, yeah, exactly, exactly. I was like trying to read it, and it was just like, you sound confused. Here are some resources for Godot and Unity and Unreal Engine. It's like, bro, fuck you. Like, no, I have my own engine, you idiot. I need to figure out how to calculate the texel space, bro. Shut the fuck up. Okay, so our range of our UVs gets multiplied times this. So this is the amount of texels per one UV. And how much one UV is in world space? Is it just one? Because that would just be 1/4. We can do that real easy. I think it might be. I think it might be. Dude, that would be so fucking sick if that was. But I don't think it is, bro. I don't think it is because we normalize them. Alright, we gotta give it a shot, bro. Locking it in. I'm locking it the fuck in. Okay, so now what we're saying is if I shoot a ray from the center of this texel and we go to another texel, how do we hit that texel? By the way, we have to go through the BVH. UV is based on the texture size. Mapping UV to world space is a thing. It is in UV light mapping. That's what I'm doing. You unwrap the UVs of the meshes themselves, and then your light map becomes a 2D texture. Okay, so how did I do this beforehand? Like leaving milk and cookies about and shit? Yeah, but he needs the milk and cookies because he's you almost tricked me. Because he's cold from fucking flying around all night, bro. Okay, so all I did is check if it's occluded. I didn't actually go to other texels. Fuck. Okay, let's give the Google thing one more shot, bro. Let's give it one more shot. Okay, I googled emitting rays from texels to other texels in lightmap making. How do I find the other texel? Yeah, I got the 3D starting point. I'm all over it. Trace the ray. Select a ray direction, the ID of the intersected triangle, the barycentric of the exact intersection point on that triangle. Okay, but how do I get that? How do I find the exact intersection point? I can do a ray triangle test. That's fine. Never mind. I can do that. That's fine. Once you have hit the triangle and hit the hit berries, you have to reverse the first step to pinpoint texel B. Use the barycentric coordinates to interpolate between the 3 vertex UVs. I love what you're telling me right now, but how the fuck do I interpolate between the texel UVs once I have the barycentric coordinate, bro? What the fuck are you talking about now? What? What is the... Okay, give me the math, though. What math do I need to do that? Bro. Okay, whatever. First thing I want to do is ray versus triangle test. I already have this, but I want to make sure. I already have this. What am I doing? It gives me the barycentric coordinates. Okay. Interpolating light map UV using barycentric coordinates during bake. Calculate the barycentric coordinates. No, you fucking idiot. I need to go from the coordinates to the texel, you fucking freak. Bro, like, you're giving me it backwards. From barycentric chords to texel. Calculate the texel's barycentric coordinates. Interpolate 3D attributes. Cast rays and evaluate lighting. Store the value. Using these exact barycentric coordinates, interpolate any vertex attribute from geometry space, for instance, to calculate the 3D world position, and the interpolated vertex normal for the texel. P world equals WA world plus WB world plus WCC world. And then normalize it with the normal. Bro. It's snowing in Australia? Wait, oh yeah, that must be great. It's not that great here. Alright. I'm gonna keep it a buck, bro. I have no clue how to do what I'm about to do, so don't expect anything great to come out of this. Because we gotta go from this point, we gotta do the Monte Carlo thing. That's baby stuff. And then we have to raycast out, walk the BVH for all of our triangles, and then hit a triangle. Then we take the coordinates where we hit the triangle, and then we need to magically interpolate to get the texel. Which I like, what the fuck are we talking about, bro? Like, it just gave me a bunch of bullshit, bro. Okay. So if we get the UVs, right? Our UVs are not normalized. They're not normalized. But we have the UVs for the whole triangle. So how do we find which texel we're in? Which texel we fall into? Well, we have the min and the max for all of it. Each texel we're in. And so all we need to find per texel is if our barycentric coordinate is close enough to where we hit, or is that just cheating? Is that just straight up cheating? Okay, whatever, bro. We're gonna figure it out. We're gonna figure this out because that's what I do. That's what I do. I figure it out. So this was my old raycast. Ray intersects triangle. That's what we need. What's this function? Ray intersects triangle. This is a camera.h function. And this one is one that I just used for everything at some point. As you can see, I did some I had to do some debugging with it back in the day, but once it worked, then it just worked forever. So that's cool. Instead of taking in a try, we'll just straight up take in just 3 points because we don't have tries. We have references to tries. Now why that is because I'm a wizard. Okay. So all we're going to need to do is we're going to walk the BVH, and then, by the way, I don't even think that this is in floating point precision, but let's not even worry about that. We're going to give the out T and the out hit point, and we're going to be a happy camper. We're going to be a happy camper. Okay. So we walk the BVH, we find the ray intersects triangle, and then from there we get the triangle. We get the hit point. I wonder what the T is. What is the T again? The T is how far... I don't think it matters. Let's not even worry about it. I don't think it's something like the D in EPA where we have to like actually translate anything. I think that it's just whatever. So we get the hit point, right? We need to go from the point to the texel. The point to the texel. Yeah, I got no clue. Here's something. Are we just supposed to oh, but if we accumulate, then we still need to find the texels that we're accumulating from anyway. So yeah, that's not gonna work. Find the barycenter relative to the triangle, the sufficient and robust way. Okay, interpolate using the weights. Interpolate the lightmap UV coordinates assigned to the triangle vertices. Convert UV coordinates to texel space. Quantize to pixel indices. Okay, we need to write this down. Vector cross products. Find the barycenter weights of the hit point relative to the triangle's 3D world space vertices. Okay, we need to write this down because this is the formula that I was looking for. This is the exact formula I was looking for. We have this compute barycentric over here, but this is a different one. Because this takes in the... This takes in the 3D ones. So Um, and then we're just gonna give out the float pointers again. You're back? Hi, back. Okay. Okay. So I am straight up just copying the code. And we're gonna just pray that it works. But this is the formula that I was looking for. So let's see if it works. Because there was no way for me to just like figure it out myself. So because I have to figure out how to interpolate all of this from a hit position into texel space. It's apparently more complicated than I thought. So if it's wrong, then it's the AI overview's fault. We're taking the length of a normal. Huh. Really? Is that really what we're doing? There's a lot of length going on here. More length than I'm used to in a formula like this. It's not really giving me a lot of confidence in what we're going with here. The next one is V2 and then V1 over TA, and then the last one is 1 minus WB minus WC. Okay. Hey, what can you do? What can you do? Okay, so apparently those weights, the barycentric weights that gives us, are what we need to multiply times the UVs to get where we are in texel space. Which is exactly what I want out of life right now. So we need to send Monte Carlo rays, and then we find hit pause into a try, and then we compute 3D barycentric weights, and then we multiply hold on a second. What? Wait, I'm supposed to multiply the UVs, but I only have X and Y. I'm texting the Google AI. Okay. That's exactly what I wanted to know. So we need to multiply each point's UV and UV.x.y times the weights. That's exactly what I want to know. Because I was like, what the fuck? Why don't we have 6? If that's the case, but we apparently multiply both x and y by the same amount, which seems a bit stupid, but nonetheless. Then we multiply times the atlas width and the atlas height. And then from there you find you do what we did up here, if necessary. Yeah, so from here then we're gonna get, after we do the barycentric weights, then we get this. We're gonna get the width and the height. Yeah. Then we get the width and the height. And then from there we need a... From there, do we multiply first? I think we multiply times the atlas width and the atlas height. And then we cast the integer. Yeah, you clamp it and then cast the integer. And then it's just the index from there. So yeah. You're fucking freezing. That's the Australian way of saying fuck. That's crazy. To do the Monte Carlo raise, I think I already did this at some point in here. When I did the balanced, I did a biased hemisphere direction, which sounds like exactly what we want to do. Probably more fancy than that, but for... I turned off the bounces at some point, yeah. So generate bounce is what I ended up with. And I straight up just like copy and pasted this at some point. But that's alright. I'm going to play with that later. But for now, I'm just going to leave this as what it was. Because I never really played around with this at all either. Back then. Oh, right. I split this into walls and... Right, because I wanted to bias it. And so I ended up... Oh. Yeah, well, this is disgusting. Okay, well. I can't believe that I did that. We're just gonna pretend like this is a fine function. It's not, but I need to make sure that everything else is working. So now that we have our position, we need to send out a random ray, a certain amount of rays. And so I'm just going to for loop through usually light maps end up doing like something like 124. Right now, let's just do 20 rays. Why are you making a sad face? This isn't sad. This is epic. This is fucking epic. Basically, so all of this, by the way, is going to be inside of a for loop that goes to the amount of iterations or whatever. Sad might. Rough might. Also, something that I'm realizing is that our object, BVH, and everything, this is going to get complicated. Because once you have multiple meshes, we have to run through both BVHs. And so, yeah, that's nasty. Vec3 dir equals generate bounce using the normal of whatever try we're on. So that's going to be MF normal. Beach. So you're just thinking about beaches right now. You're just that cold. That's crazy. That's wild. So we're going to ray cast. I think we're going to ray march. I guess that's the only way I can think of doing it. Just ray march through the BVHs. I don't know a not lazy way to do it, so we'll just do it the way that I know, and then later I can look up a better way of doing it, but I'm just going to keep our old function that did it. Except, obviously, it's going to have to change somewhat. Because we used to just, like, go through the map. Now we're going to have to go through the BVHs. We need a function that traverses the BVH. I think that we did it manually before, so I need a function that does that. And there might Minecraft is a trip, man. I used to play a lot of Minecraft when I was a kid. Well, not a kid, but when it came out, when it was in beta, I was on that shit. So yeah. Ah, shit. Okay. Mature adult kid. I am kind of a mature adult kid. Where I did it is actually in camera.c when I was doing the collision logic. Then I went through the BVHs over here. Find first collision. So I traverse over the meshes and then the holes. This is the per triangle BVH though, not the scene node BVH. So I also have to make a function that does that. Where am I going to put this? I'll put it at the top. You're dusting it? I feel like I did. I don't want to have to write this again. In our rendering, I had like a debug thing that did this. Right? At some level I did. No, this is the holes. God fucking damn it. God fucking damn it. Okay, we have to do it. We have to do it from scratch. Actually, no. Let's just copy the thing from camera.c that does it. That does this. So this is exactly what we want to do. This is the exact code. Bro, incompatible pointer types? What are we talking about, bro? This is BVH nodes. Oh, it's a vector. Oh, it's a vector. I tried Objective-C? No. But I feel like I've probably bumped into it quite a bit while just writing C. One min try? Yeah, one min try would probably take forever. Yeah. Okay, so we're gonna start at node 0. And here I'm checking if our point is in here, so I will take in a vec3 p, and we'll just check against the left and right AABBs. So if we don't have a child, then we're just gonna return, well, returning false would probably be a bad decision. But for now, we'll just return false, yeah. Actually, yeah, so let's return an int, and this will return BVH node index or -1 if no node found. What is for C2 versus C3? What if it was just C plus? I think that's a thing or something. Maybe not. Maybe we should give the pointer to the node now. Just because I'm too lazy to write it otherwise. Do I want the pointer? Yeah, let's return the pointer. Why not? So what I was thinking about while I was writing this is that you could literally just pass in BVH node pointer nodes into here, and it still works. So we don't even have to, we could just do traverse BBH as a generic one and not even have to write anything specifically for the scene BBH or anything else. So I think like this is exactly what I want out of life right now. So while so I don't really remember how this works, by the way. So this is if we go out of bounds, which I don't think we have bounds, which is pretty worrisome. We probably do want bounds. Actually, let's just make a const, just for now, just a const float, x min, where we're gonna do like -1000 to +1000, just so that we don't get an infinite loop, because that would ruin my day at this point if we had to deal with infinite loops on top of everything else we went through. Okay, so we're just gonna say in my old engine everything was voxel based, so we had a map. Actually, why am I doing this? 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 Literally, just get scene data pointer SD equals globals dot scene data, and we have, don't we have a SD dot, yeah, so ABB bounds equals SD AABB. The fuck is wrong with me? I already have that abstraction. Oh right, we only had X and Y. Oh well, now we obviously have to do this with Z as well. F sharp is an American psyop because they hate working in things with Celsius. Wait, F sharp is a real thing? That's just a note, bro. Let's check AABB. Where's my function? Point in AABB with our current X, Y, and Z. And then if we aren't in the scene AABB, then we just exit out. F sharp is a strongly typed multi-paradigm programming languages and .NET, and I don't have to read the rest. Linux, Windows, and Mac OS. Okay, so why not just use C sharp? So what is the purpose? Hopefully that these functions can work in more than two directions. I didn't really consider that. I think it's fine. I think it's fine. I may have to do some working, though, with it. Don't really remember how it works. I'm saying that a lot recently because I am just taking a big walk down memory lane, you know? But it is true. I don't really remember how it works. Wait until you hear about F++. What is F? What is F? F me, what is F? Okay, so this is confusing. This is confusing. I don't really remember how to do this. So if T max X is less than T max Y. Right. Do I have a raycast in here that is that has a third dimension. This raycast against node hitbox is OBB. So that's not what we want. So I'm gonna guess no, that we don't have that. I think I did at some point. Oh, I do have this. Excellent. This is exactly what I was looking for. You love to see it. You love to see it. You love it. You love it. You love it a lot. You love it a lot. You love it a lot. This is exactly what I wanted, see? So that I didn't have to figure out that complicated logic anymore. Fat or fabulous? 231k subscribers. Holy fucking shit. Apparently, F# is C# on steroids. That sounds like something that I would hate. So thanks for sharing that with me. Thanks for doing that. This was apparently lighting logic as well. Raycast world voxel the sky. This was how I did the fog. This is how I did the fog. Uh-huh. That was how I did the fog. Great. If not, hit found. Right, this was if you didn't get any occlusion. Right. Then as you step along the ray, then you added fog to the volume. That's what this was doing. Cool. Well, that was a nice little trip down memory lane. Okay, so we want to BVH node pointer scene node equals traverse BVH using the cast vec for globals dot scene data dot and the P will be wait, hold on a second. This is in oh, these are integers. Sir, we're gonna need you to not be in integer space. That's what we're gonna need. I always see it on the list of languages, and while I already don't like C, yeah, it's C#, yeah. Yep, producer. Yep. I am in agreement with you. I think it sucks. I think it's terrible. And I'm glad that I don't have to use it. So there we go. Why is this? Oh, it probably wants a pointer, huh? There you go. I'm giving you what you want. Give me what you want, what you really, really want. Okay. So what are we mad at here, huh? Why are you so mad, huh? What, this isn't happy enough? Oh, traverse BVH, it's saying that it doesn't give you anything. Why does it oh, we probably just don't take it into the file. Oh, yeah. I don't know why I'm so stupid, but that's fine. Been around since 2008. It's 1 year old when that thing's dropped. That's crazy. That is crazy. I was straight up. I saw Finding Nemo in theaters. and I peed my pants. I'm not joking. My parents love this story. I peed my pants when the shark came on screen. Real ass story, bro. We need to go the C node count. Yes, 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 yes. If not C node, return hit found. The difference between assembly language and assembly script. What type of slop is assembly script? That is the most slop-like language I've ever heard of. You're not speaking English right now, that's for sure. Dude, I'm writing some heavenly code right now. I just want to say, not to seem pompous or anything like that. The code that I'm writing now is just transcendent. Scython? Holy shit. So reminding me of like the people that like listen to like the music I like and then get the wrong idea. Like people use C and like, how simple. I can't wait to fuck this thing up even, you know. Even though I like it, I can't wait to make a Python version of C. I can't wait to make a brain rotted version of C so that I can like it. It's like, bro, it's like the same people that listen to Elliott Smith and are like, bro, I understand this on a deep level because I like have had my heart broken before. And like, bro, like, shut the fuck up, bro. Okay. Not to gatekeep, but bro, like, get the fuck out of here. Leave me alone. If try T less than out hit T, the fuck is try T? Oh right, we're now at the level of we have to traverse the other BVH. So now we have to go BVH node pointer, mesh node equals m bvh m nodes casvec m nodes bvh node. Then we want to Oh yeah, we want to do this, but with M nodes, M Night Shyamalan. If not, mesh node continue. Okay, can't forget that. This is gonna change to scene indices just to because we're getting into it here. So now we want the mesh indices, which is going to be the M leaf indices. Okay. We're getting into it. We're almost there. We're almost there. Okay. So we're inside of the mesh nodes. We've traversed the mesh nodes. Okay. Now we have to look through, lock the fuck in. We're gonna go J. We got the J. We got the J's on. Dude, when I was a little white boy going to 5th grade and I got J's, dude, everybody thought that it was the sickest thing ever. High level shader line. JJ sharp and JJ plus plus. Dude, what are you talking about? Okay. Okay. So now we are going through all the triangles, and now we test it. Now we test it. Lock the fuck in. So this try, we're not giving it a try anymore. We need to get the mesh face. Mesh face pointer MF. MF equals M tries. We need to cast vec it. Cast vec M tries mesh face. And then we need to do the same thing with point. We need to get the points for the mesh. We're gonna cast that. Vertices. And then we get the mesh phase pointer MF equals at MF's J. No, not J. Indices at mesh indices J. Okay. And now we drop the absolute sick bomb that is going to be this function signature here, guys. We're just going to bring it back a little bit because we're going to have to do some work here. This is going to be MF indices 0, but that's indexing into points. And then you drop the dot pause at the end. And now we just got to do 3 of these real quick. Jython, bro. Lego script. These are not real languages. I thought we had too many languages already. You're just reinforcing that notion. Sorry, I just had to cry for a little bit. Okay. Out hit. Out hit was a ray hit thing. Let's actually go to the ray hit. Where is this? Okay. T, pause, and the pointer to the try. We're going to make something like this. This is like a really good struct to have. But I don't know how, like, if we're going to do a pointer to the try necessarily. Collision triangle. I don't think we're going to do, we want the T and we want the pause. But do we really want the try? We do want the try. But like, I remember the pointer that tried giving me some troubles. Not gonna lie. Not gonna lie, bro. Yeah, let's just do a let's just do one of those. Dude, I'm gonna be so happy when this is fucking over. Holy shit. And then you just return true. I think you just return true if you get it. By the way, I have no clue how we're gonna test this out. Also, what I'm realizing now is that we only initialize BVHs for the triangle, for the individual triangles on static meshes, which makes a lot of sense, but also I have no clue what we're going to do in terms of light map for those guys. So I feel bad for those guys personally, but for now we're just going to ignore those guys. Q kind of sounds based. Unicon. Z++. Now that's one that I can get around. Get behind. Okay, so now we find hit pause into try. So raycast world using the origin pause with the dir, and we want to make a ray hit. Give it the ray hit. We want to make sure that hit.try always equals, well, did hit. So we hit, we have a triangle, and we have, what do we have inside of it? We have the pause and the T. Absolutely. Okay. Lego script is for a product you used to own. That's crazy. Some other things that we actually need in this before we get away from ourselves, we need the mesh index actually. We need the mesh index as well as the try, because once again we are going through all of our meshes as well, right? So also this isn't mesh indices J, this is mesh indices J plus the mesh node first index. You can't forget that. Absolutely can't forget that. So how do we get the, so it's this, we need this. This is the most, this is the most nesting I've done in this project so far. The fuck is Hollywood? That's a language, bro. That also sounds like something I would hate. So that does sound like something that I would fucking hate. We just made this file and it's already 1,000 lines. We made this file yesterday. All right. So we're gonna get the mesh. For the hit mesh is globals.meshes indexed by the hit mesh IDX. Then inside of this we're going to get the mesh phase pointer hit MFs equals the cast vec of hit mesh tries, and we're casting it to mesh face. This is probably the hardest part of the engine so far. That's a vec. That is a vec, I guess. I probably already have it then. Yeah, I do. Chicken? What is chicken? That's a language? I thought you were just saying chicken for a second. It's getting so ridiculous to the point where okay, we found it. We are at the triangle. We've now hit a triangle. Let's fucking go. Okay, so we need to compute the 3D barycentric weights. Okay. Compute 3D barycentric. Absolutely. So we're going to make 3 floats here called B00 because we already have them. B0 and B1 and B2. Time to switch. Python is a superset of programming language Python. Oh, the superset. Performance comparable to that of C. That's fucking nonsense. What are you talking about? Performance, dude. People make me sick, dude. Like, genuinely. People make me fucking sick. So we need to get the try points. We need to get the try points. I wonder if we cache them or not. Multiply each points. Right. Let's just be very explicit here. So let's get all the points. Oh, you got it working? Nice. Nice, good job. We're fucking rocking, bro. Are you kidding me? We're getting it all done right now? We're getting it all done. Okay, so we need to multiply each point's uv.x and uv.y times the weights. Very important here. Now, how do we get to the UVs from this? Oh my god. Oh my god. I think I'm gonna have a mental breakdown. I think I'm gonna have a fucking mental breakdown. You're joking. You're joking. You're joking. You're joking. You're joking. No, it's fine. It's fine. It's fine. It's not that bad. It's not that bad. I have to just lock the fuck in. I have to lock the fuck in. It's the hit MF has on it the UV island, and also We have these, we have these, we have these, we have these. So and now we get from within here, we get the light map UVs from that island. We get to hit UVs from hit island UVs indexed by hit UV IDX. Okay. Holy shit. Python? Python language, you know. Python was initially created in late 1997 to replace C with Java. Oh, replace C with Java. Aha. Yes. Exactly what I want to hear about. Replacing C with Java. Ah, yes. Is this why everything runs like ass today? Is that why? Well, I'm glad I know who to blame. Multiply each point. Okay, so now we multiply the UVs on the UV island. Okay. We hit the UVs on the UV island to all of the weights. So basically what we did up here hit UV, UV's 0. I'm just writing it all out because at this point it's like the most complicated code of all time. So from within here, we need to multiply UV0 dot x times the weight, and I'm going to assume that this is it. That we multiply it like this for each of the points in this order. And then we multiply times the atlas bounds. We're almost there. So UV0 dot x times the atlas width y times the atlas height. We can write this in functions later. I don't really have vec2 stuff done. Clamp and cast to integers. Right. So I'm almost at the end. Like I just realized this, like as I was typing these words, that I'm like actually I might actually like finish this. Like, isn't that like the craziest thing to you? Like, I've been writing just code, like hard code, like not debugging, not just code for the past like hour, just like straight up just writing code, just so much fucking code. Like it's and we're almost done. Like it's crazy. It's always been, hey bro, this new language Rust is just gonna yeah. I mean, honestly, Rust, like I've said it before, I think Rust is probably the best out of all of these new Zoomer languages. Like Rust is a solid language. It can do, everything, and it's very versatile. It's just compiles like complete ass because it doesn't trust you to not make memory leaks, and you have to write everything in unsafe blocks because it's just built by people who, I don't know, who just don't, don't, I don't know. I hate the fact that like in Rust you have to like write things in unsafe blocks that like oh, it's gonna create a race condition. Like, motherfucker, I know, but it's like this is like coding is all about like sometimes you just have to write the risky code. Like it's it's like training wheels. Okay. Guys, guys, that is the index we hit. That is the texel that we hit with our array for the light map distribution. That is the index. We walked 2 BVHs to get here. We did countless barycentric interpolation. And now I want to also make sure when we get our shit out of here, we also have to make sure that there aren't nons here, because that is possible. Oh, okay. Now I have no clue if it's gonna work, but okay. Oh, bro. Okay, so I have no clue how to actually test this, like that this works. I have like a 0% idea how this is gonna work. Like, holy shit, this is like, how do I even test this? I also want to go to our initialization for our light map and make sure that we calc it. We do calc the buffer. Okay, well that's fine as long as we calc it. You did it? Is it confirmed working? That's crazy. Caught up in a bad romance. Oh. Okay. We're not gonna freak out. Seg fault in traverse BVH. Okay. Nodes equals 0. I gave it a no node. No. I gave it a node without a node. Oh, node. I'm fucking losing it. Okay, lock the fuck in, because we gotta figure this out. Okay. So we cast the M nodes. if m nodes dot count less than or equal to 0, continue. We should have our scene data nodes. Depending on the model, it can be slower. At a lower res, like 32, it's 9 seconds slower. But at 64, it's just a few seconds faster than prims. Huh. So you're saying that it works, that... So you're saying that the minute it has an overhead? Oh, I see. At a lower res, it's 9 seconds slower than just prims. Oh, I see. Yeah, so at a fast thing, it might be good. So why don't we have a BVH? Don't we still make a BVH? And it's scene BVH, and it mesh, add mesh to buffer. And it's scene, and it mesh. And it mesh with true. And it try BVH if BVH prim. And I have it at true. So why aren't we stepping through the BVH then? Why aren't we stepping through it? I'm going to assume that this is what happens. No nodes, yeah. Right now we can just hard code at m equals 0. No nodes. What? The fuck are you talking about? There's no nodes. I mean, I'm just gonna lose my fucking mind or what? Why does this not have nodes? Like, after we init it... Oh, fucking Christ, I didn't get rid of the other printout. No nodes. Are, like, what? So more triangles or more res is better? Yeah. Yeah, well, I'm glad that you got that figured out. That seems like it's pretty important then, if it's good for bigger models. Hold on a second. It's not meshes nodes, is it? It might be. It might be... Oh, it's in holes. It's in hole 0. Oh, shit. So it's not in the mesh nodes. It's per hole. So let me get that for a sec. It's going to be convex hole pointer holes equals the cast vec for m holes convex hole, and then j equals 0, or k equals 0, k less than m holes dot count, k plus plus convex hole where hole equals at holes, okay, and then everything gets put in here. A lot of nesting, not that happy about it, but here we are. And instead of m nodes, it's going to be hole nodes. And hole leaf indices. Alrighty. And instead of m tries, it's going to be the whole faces. Oh shit. Oh shit. Oh shit. Oh shit. Yeah, we're going to have to add it. So maybe I need a max depth. It's slow and shit. So BVH soon. Yeah, honestly, I think BVHs are almost easier than KD trees. It's just the indexing, like I told you about. But also, KD trees are good for, I think, what you're doing. No. Where is the ray hit? The ray hit also needs the whole IDX. Because our BVHs go by whole, shit. Now, yeah. I think what I'm realizing now is that our triangle BVHs need to not be done on the holes. And they need to happen over the just raw triangles. Because I need to get to the tries to get the UVs. So this isn't gonna work. We actually can't do this. We had to do it how I did it, but unfortunately our code was written by a stupid person. Well, I just didn't think about it. Well, I mean, I had a reason, right? Which was like, what if you need to split this up into holes later? Right? Like, what if you need to split it up into holes later? Because you have really big meshes and you need different holes so that you aren't walking like a massive BVH if you have like a lot of terrain. But I didn't really think that my triangles would have UVs on them. We could store in our whole triangles a reference to the other ones. But yeah. Said init try BBH should happen on the mesh itself, at least for this case. So I don't know, maybe we just have a version that goes over the hole instead. And you need octrees? No octrees. Yeah, max depth for sure. Yeah. Max depth for sure. We could just copy the code and then do it for the actual mesh tries. Instead of doing the whole. Or we could store alongside these triangles a reference into the original tries. Isn't it the same though? Aren't they the same? When I init them, I just copy them over. And then I just init try BVH on the whole rather than on the mesh. They actually line up. So technically I could, at least for right now, just actually do this and then just use the indices to get the try, since they match up. I accidentally left some debug thing on. The time to generate is 0.05 seconds, so nope, it's crazy fast. Do you think that that's real or is that a bug? Fuck. The idea was that if you have, like, you could partition the holes separately. I think it's a stupid idea, though. I think it's a stupid idea. Yeah, let's just undo it. Let's just undo it and then do it the way that I was gonna do it. The power might go out. Here comes the thunder. Thank God I have a laptop, huh? It's real? Wow, nice. That sounds pretty fast. Alright, let's copy it. The good thing is that I can just replace hole with mesh pretty much exclusively, and it should be fine. I don't have to actually change the code. It's the same thing. It's just with different names. In fact, I could probably do this very easily. This is going to be like a few seconds, really. Oh, I fucked it up. I didn't copy the whole thing. I need to copy this now. Yeah, not that easy. It's not going to be that easy, but usually when refactoring something like this, I make a mistake by accident. And so I'm hoping that I don't do that this time. Usually what happens is that I like usually I just rename something that shouldn't be renamed or like needed to be renamed to something else. But I think this is fairly straightforward. It's the same exact data, just over a different structure. The worst part is that now a lot of the references to that code are going to become deprecated because a lot of our debug stuff went into holes to do this sort of thing. Oh wait, whoops. This is supposed to be BB instruments, but okay, so let's see what's happening now. I doubt that we don't have nodes now. Are we stuck in an infinite loop? Or something? Oh, let's not do that. Let's not do that. I don't like that my mouse is unlocked. Fuck. It's raining. I'm gonna close the window a little bit. Okay, it's going. It just takes forever. Let's go to 1. Let's go one ray. It looks blocky. Yeah, that's really fast. Yeah, that is really fast. Oh, and then it crashes. Oh my god, you're fucking kidding me. That after it finishes, it crashes. That's so fucked. Okay, well, that probably means that it's gonna crash if I just don't generate it. And I just render. Yeah. This probably has to do with our rendering not having to do something with the find first collision. Find first collision probably has to do with the holes again. Yeah, holes. If holes J BVH prim. Just put in the M nodes. That should do it. That should fix it. Oh my god. Come on, man. What? What is the problem? Node first index to FS. Oh, this is all. Why is this mesh dot? Should be M. Okay. Yeah, that sounds like it's working good then. Okay, so this is working now, and now when I go into here and I put it to the UVs, we should at least see something on the screen. Okay, nice. Good. Okay, now let's bake the light map. I have a feeling that maybe we should put this to like 0.05 instead. Yeah, this thing is taking a long time to bake. Like a very long time. Very long time. Oh, now it took immediately. Oh my god, fellas. It looks like we have things going on. How is it so fast? I thought that it was taking forever before. If I go to 12 bounces, then it's gonna go fat. Then it's gonna take forever. The weird thing is the aliasing. That's the weird thing. Also, it just feels low resolution. That's a insane res. Yeah, but why would it crash though? I don't know what the artifacts are with the crosses. That's what I'm trying to figure out. I wonder if it has something to do with their padding. We should go to like one ray again because we're just going to be testing out the padding and stuff. I use a padding of 4. Let's try a padding of 0. No, yeah, it's still there. A higher padding, maybe? It's a lot of pixels. Yeah, that sounds like it. This, I added 0.5f into it before I did it. I wonder if I have to do that after as well. I do that before I multiply times atlas width or whatever. It's a lot of pixels. That's a lot of pixels. That is a lot of pixels. Yeah, that didn't seem to work. Let me see if I mistyped any of this stuff. Doesn't look like I did. Wait, hold on a second. I'm not actually using... Wait. But this... Oh, shit. I get the integers out of this. Hold on a second, let me check this. Oh, hold on. So I need to multiply the UVs times the weights and then add them up across the thing. And then that's what I get, how I get the... No wonder why it crashed. Oh yeah, maybe it was a memory thing, yeah. Yeah, that's pretty massive. What am I gonna call this? I'm just gonna call it chord, actually. uv2.x that x 1.y uv0.y plus uv1.y plus uv2.y. Chord. Dude. Oh my gosh, I think it's happening. I think it's happening. I mean, there are still some seams. It does seem to be that way. Ha 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 ha. Also, texels per UV unit I think is too high. Or maybe it needs to be higher, and that's what it is. Because everything seems super pixelated. Oh wow. Putting this higher makes it really slow, actually. Holy shit. Look at that high resolution. There are some seam issues, it does seem. Does seem. Yeah, like, what is going on there, huh? You've perfected the speed? Well, that's nice. I need to perfect the speed of this shit, that's for sure. It's gonna take me forever to do that. This shit needs to be fast. The thing is, without this, if we just do raw indices, it's just perfectly flat and clear. So it has to do with how we're doing our weights and shit. There has to be something that's causing it. Oh wait, hold on. I'm supposed to go UV00. This looks more reasonable. The reason why this is a diamond you can't really see is because it is a physical diamond. Our collision isn't really working. $17 FPS looking at it. That's wild. Not sure. Not sure where we went wrong with it. Or maybe it's... It would kind of feel a lot better if there was multiple, you know, if we had more rays going on it. Which I can try. It's just going to take forever. Like over here, it seems like there just isn't like really getting anything. Yeah, might have to do some testing with it. But I got it kind of working, which is all we really care about. We go from MF normal. Yeah. Like 15 FPS sharp. Instead of it's kind of hard because the generate bounce thing is already biased, so it's kind of, I kind of wish we could just like I don't know. Do random rays just to see what that would look like. Yeah, sure, let's do it. I used to do all this janky shit because I didn't know that ran max existed. It was funny. Alright, let's try this. Yep. Still happens. So I don't think that we're doing it correctly. Brand Max? Yeah. I didn't understand that that was a thing, and so I would just like um I would just modulus it with a large number and then divide by that number. Oh, good times. Good times. Good shit. 128 is on the high. Yeah. Yeah. 128 sounds good, yeah. Let's just make sure that my compute 3D barycentric is correct. Take the cross of v0 with v1. They take the length of that. You divide it. You take the cross of v0 with v2 and v2 with v1. So you take the length of that, you divide it by the total area, and then you subtract them. Just to be sure. Just to make sure. Nah. What is rand max? I mean like rand. Like rand as in how you get random numbers in C. I didn't know that there was a rand max that you could divide by to get random numbers. So what I would do is I would just modulus it with like 100 and then divide by 100. Not 100, more like, 10,000 or whatever. That just made everything go away. Okay, so that probably isn't it. We might have to add 0.5 somewhere. Because that's how when we put in these points, our point initially what we had was plus 0.5. when we put in our point. So maybe our hit point, maybe our hit pause needs to I'm just spitballing. Oh shit, that's a bit ugly. That's a bit ugly indeed. Yeah, I don't know. It might be actually how we allocate it as well. Yeah, I wonder why that's not getting any. Actually, here's a question. I wonder if we're shooting rays on the inside, and that's, but that wouldn't cause what I'm seeing. So what I'm seeing is a definite aliasing issue. It's gonna be oh god for world space. Yeah. Yeah, some of these just don't get anything at all. I kind of want to compute the barycentric for that as well, but I mean that has to be 2D, so or actually is this supposed to be hold on, let me check this. Is that supposed to be the PA or the P0? Meaning the point on the triangle or the point... It is supposed to be this. Maybe... but no. Actually, hold on. Let's test this down here. Let's only add it if we get through that. World space 1 should be faster to compute. Yeah. Yeah, definitely. So it's definitely not that. We get clear stuff all around for that index. It's only when we raycast world that we have an issue. Maybe the issue is with my raycasting then. And my BVH then. I mean, it is fairly complex code. We could just straight up remove the BVH to test it. And instead just go based on just 0. We just remove the BVH to test just what's going on, and just go, instead of just doing this, let's just go through all of the tries. And then the try will just be J, and the mesh IDX will just be 0. Just for hard coding things. The raycast might be wrong. Nope, it's the BVH that's wrong. Well, that fucking sucks. That fucking sucks a lot. You hate to see it, to be honest. Has to be the BVH, right? Has to be the BVH, right? Yeah. I think this continue is scary, actually. Hold on. It may not actually be the BVH. Let me just nest this real quick. No. Especially for 2 seconds now something is hanging. Oh, damn. Yeah, this is like kind of a Hail Mary idea. Yeah. I guess that the ABB is broken on the inside, and that's kind of the problem. Which is something that feels kind of beyond the scope for today. Especially considering that I just copied all of the code and I had to change it. Like, God knows if there was something that I fucked up or, you know, or what. I try a higher depth for it. Yeah, no. Don't have SDF gen, but I'm trying to use the SDF when it doesn't exist in the debug renderer. Oh. Oh. Hold on a second. I didn't cast this to point. Please tell me that that's the bug. And it's not actually like a problem with my BVH itself. Like, please tell me that it's something stupid like this. Like, please. Okay, thank God. I thought we were gonna have a real problem for a second. I was like really worried about it because of how long I spent. Well, I didn't necessarily spend like forever, but how long I spent getting these to like a point where they were solid, you know? This doesn't matter because our centroid test doesn't even happen here, so it's just extraneous code that we'll get rid of later. Okay, so going back here, we can now just revert the code to what it was beforehand, before I started like getting unbelievably tilted. I did also change something else somewhere, which was our traverse BVH thing. Yeah, we don't want to go by dist. We don't want to go by dist if we can avoid it. And let's just check that this all works. Okay, looks like it works. Okay. Don't know if I'm doing static object, I should try at some point. Yeah, this is what it's gonna look like. Okay, so all this is it's just proof that what we have is working. There are some lines on the bottom, but the top looks fine. The lines on the bottom don't really worry me because I think that it's from within that they're getting. Yeah, there are some lines that are, you know, a bit suspicious. Like I'm not gonna lie, there are some lines here, but the only reason you can notice the lines is because we are only doing one bounce. Like if you accumulate light over like a bunch of different like times, then I'm pretty sure that it becomes unnoticeable. Like yeah, it starts to become less noticeable, or actually more noticeable now that you mention it. Now that I mention it to myself. So those lines are probably aliasing lines that that are from something. So we have to figure that out. But anyway, I don't know if I'm gonna leave it right now, but I think it's beyond the scope for today to like add another object and see if it occludes light and shit like that. The reason why it's beyond the scope of today is because I have to add abstractions for traversing the nodes, because how we have it right now is that we can traverse the scene BVH and find objects inside of it. Sure, like that works fine, but what doesn't work fine is our once we start traversing the stuff inside of the scene BVH nodes, because the meshes themselves aren't internally translated their points. Actually, that's not that bad. That's really not that bad. All we have to do is transform the points themselves by the model matrix of the mesh. The model matrix of the mesh. But yeah. If you're making indirect, do a 3x3 luma average blur. That works well. Yeah, I'm gonna have Gaussian blurs. I had blurs last time. I don't know if it's different from a Luma blur, but yeah, I had a couple of different blurs that I did last time. Um, Mainly worried about what I'm gonna do is I'm gonna do like a radiosity thing, which is the basic thing, but it's I think it's GI, right? Is it's gonna be every texel is gonna emit light to everything else. Every texel is gonna have energy that it's going to propagate to other ones, and then you just loop it. You just loop it a bunch of times. Um, but yeah, to do that, we do need to apply the matrix for the mesh. We can actually get this. So mesh node pointer. By the way, also mesh nodes are the ones that are going to be duplicated per mesh instance. We don't have that set up yet. So right now, the meshes just see the mesh nodes, and that's just the way it is. The meshes link straight to the mesh nodes. So we can get the mesh node like that, and then we need to, for each triangle, transform the triangle by the model matrix. I have to look up how to do that. I think that you just literally multiply transform triangle by model matrix. Multiply each vertex by the model matrix. That's what I assumed. So from here you're gonna have a vec3 PA equals direct and indirect equals GI. Your baking surfaces are yours. Does it need to be edge aware? I see. 92. That doesn't seem that bad. I'm assuming that you're gonna like write these to files, and this is gonna be like completely offline. Like that's obviously what my baking is gonna be. Like I mean, to do light map baking in real time, like this is my light map baking is probably going to literally take like hours for what I'm trying to do. MN local matrix by PA, and we'll do the same for PB and PC. PB and PC. Okay, now let's try to see if we can have another mesh. Let's see if we can have another mesh without breaking everything. So let's init a new mesh, init mesh 2. And we need to also do all of the initialization routines for the second mesh. And the second mesh will have a, it's kind of sucky how I have this, but that's all right. And be one mesh node, yes. And then this one's just going to be like at like 6, 10. Oh, but we need to have that before all of this. We need to have that. We need that to happen up here. Okay, let's give it a shot. And instantly crash. Why is that? Did I hard code something while I was testing things? Hit UV UVs and generate UV light map. Hit UV UVs. That's at 1010. Okay. 1010. Right at the end. Hit UV UVs. Yeah, I'm not sure. We should be able to just build adjacency maps and stuff, and hit UV islands happens over all of the islands on LD. Oh wait. Oh wait, no, but each one has its own pointers. Each mesh has its own. Alright, peace out. Each mesh has its own pointers to the thing. I may have made something a mistake. When I build UV islands, do I... Oh, that's right. That has to go in a different function. That has to go into here. I initialized it twice. Oh my gosh, it's dark. I can't see shit. Why can't I see shit? Saying bad words, saying. Why would it get darker? Huh. Okay. It does seem like two meshes makes everything not work. Hold on a second. It might not actually be that. It might be that the multiplying by the model matrix, actually. We never tested that with one. Well, it would have been impossible to test with one, to be fair. I've been having trouble finding this fucking function. But yeah. It may be this. Huh. Let's try something. Let's try one mesh again. Let's try one mesh again. See, that's what I'm worried about. Even with one mesh, this isn't working. Okay, this works though. Is it because the model matrix isn't set up in the beginning? Or what? Oh, you know what it is? I don't actually transform the original position by the model matrix. Like on incomingness, I have to... Oh, this might get more complicated than I think I'm prepared for right now. It's not just that, it's also the initial ray itself has to be right. Alright, I'm gonna get out of here soon. And then we'll do mn local matrix. And we will do pause. Does it work with an identity matrix? No. Let's make it an identity matrix for sure. No. I wonder if mat formal point is it might be for row major. Mul M4V4 might be for row major or something. Maybe we are transforming the wrong things. But that would make sense to me. All right. Yeah, I don't know. I'm probably just gonna have to. We can check if it's row major right now. I can look it up. Okay, so let's test this against what I have. So yeah, this is column major. But maybe I need it row major. I'm gonna start putting R at the end of my row major stuff because of reasons, right? Do you just doesn't this just change into A's? Fuck off. That part should still be the same. Let's try it. Yeah, it looks just about as fucked up as it was before, to be honest. I mean... Hey, what's up, Isabel? It says there. I think it translated radiosity or working at aliasing. No, what I'm trying to figure out right now is how to get it transformed by the model matrix while I traverse the BVH. So that's kind of the painful part right there. Is that I don't know if something that I have is rho major or what. I mean, surprisingly, all like the texel stuff and the UV unwrapping stuff works good, but unfortunately, I'm not out of the woods because I'm trying to do these matrix multiplications and to get everything into world space. So obviously, everything there are some seams that I have to figure out, but it's it's working fine, right? So you need have a yeah. I have two BVHs. I have one that has all of the meshes, right, and then one that has all of the tries on the mesh, right. And so I need to figure out um, why this isn't working. I googled it and it said, "Bro, just multiply all the points by the matrix," and I did that, and that doesn't work even when I have an identity matrix. So I think something is is kind of fucked up probably within my logic somewhere. Is that a row major or a column major identity matrix? I don't know. Yeah, it is row major. So I was right to change the other thing to row major, but yeah. Does your system differentiate between matrix translation being taken into account? Yeah, it I have different ones for direction versus point, if that's what you're talking about with the W being divided or whatever. I'm pretty tired, so I was about to leave though. I did just make a row major version. I think that this is row major. I just transposed it. Maybe I did it wrong. But I thought that this would be the equivalent of doing it the other way. Because this is column major, definitely. So I was like, okay, well, let me just swap it. Okay. Yeah, it looks like I did do it right. Hmm. Yeah, I mean, I tried both, but I'm not sure. I think it may be that I need to also translate something else. But if it's an identity matrix, then it shouldn't do anything, which is confusing to me why it messes things up as an identity matrix. Hmm. Well, I'll probably figure it out tomorrow. I got a lot done today. I got the whole UV unwrapping thing working, but yeah. Oh, you know what it might be? It might be that I need to also when I traverse the BVH, I need to Yeah, it's kind of complicated because when I traverse the BVH, I have to multiply our position by the inverse matrix. So good job. I am proud. Oh, thanks. Yeah, I've gotta figure it out. All right, I'm gonna get dinner. So, all right, peace out.